bit. I think if you guys remember us talking about polynomial functions where we were solving quadratic equations and things like that, we're going to be looking at polynomial functions again. We're not solving them so much as finding solutions. We're not like solving for x, like x equals. We're saying, okay, if I put this value in, what does it equal? So it's a little review. So we have a couple words that we're really going to be using a lot. The first one is going to be a degree. The degree is the highest power in the function. So just kind of remind ourselves what a function looks like is like if I do x squared plus x minus 3. Okay, where I have variables with exponents, okay? Or I could have just even like x plus 1 or something along those lines. So these are what we call polynomial functions, okay? So the degree of the actual function itself is the one with the highest power. So this one right here has a degree of 2 because 2 is the highest exponent, okay? The degree on this one is 1 because that's the highest exponent. So if someone says what's the degree of the polynomial function, you put it in standard form, and then whatever the exponent, the highest exponent is of that, that's the degree of the polynomial. Okay? So standard form, hopefully you guys remember, is putting it from the highest power to the lowest power. Okay, so we arrange them from highest to lowest, so that'd be like going from, you know, the x nth power plus the x nth minus 1 plus the x nth minus 2, etc. So it's like x cubed plus x squared plus x1, whatever, from the highest to the lowest. Okay? And once it's in standard form, then you look to the degree, the highest degree, and then that's the degree of the polynomial. Okay? And then the leading coefficient is going to be the number in front of the highest powered variable. Okay? So it's the coefficient that is in front of the highest power. Okay? So if this was like a 2x cubed, then the leading coefficient would be 2. Okay? So hopefully those three things are review or a little flashback memory, okay, because we have talked about all that before. The one thing in a polynomial you want to remember is that exponents are all positive whole numbers. So such as 2, 7, 9, whatever. They're not negative and they're not fractions or decimals. Okay? Alright, so what we're going to be focusing on is looking at the degrees of them and then kind of what their graphs look like. We're not going to be, quote, graphing, like doing little t-charts and things like that, but we're going to kind of be able to look at the function now and be able to know kind of ideally what it might sketch out to generally be. Okay? And you can do that based on the degree and the leading coefficient. Okay? So if I have a degree of 0, okay, then I'm actually dealing with a polynomial function that is what we call a constant. Okay? An example of that might be like y equals 4 or f of x equals 4. Okay? So basically you have a function that is just a number. It is a constant. And if you recall, x to 0, a variable to 0 power equals what? 1, right? Hence a constant. Okay, so you actually could have an x to the 0 here, you just don't see it because it's actually 1. Okay, so a degree of 0 is actually a constant. A degree of 1, okay, is what we call linear. An example of that might be y equals 2x plus 1, or maybe y equals 2x, can have a constant to it or not. Okay, those are examples. And a degree of 1, we call it linear because if I would graph it, it would be something like this. It's a line. Okay? A degree of 2, okay, any guesses on what it might be called? Quadratic. Okay? So a degree of 2, so an example might be 3x squared plus 2x minus 1 or something. Okay, we have a degree of 2. See how the squared is the highest degree? That's a degree of 2. You guys remember what a quadratic graphs out to be? Yeah, parabola. Okay. So when I'm talking about the degree, notice how what I'm looking at is it's in the polynomials in order, in standard form, and I'm looking to the highest exponent. Notice how the highest exponent here is 1, the highest exponent here is 2. So that's what a degree of 2 looks like. Okay? So if I do a degree of 3, alright, I might have x cubed plus 1. I might have 3x cubed minus 2x, something along those lines. So again, once it's in standard form, the highest exponent is a 3. That's a degree of 3. Okay? We call this a cubic. Okay? And if I would sketch out a cubic, it might look something like this. Okay? And then finally we have a degree of 4. So what's my highest exponent going to be? X to the 4th plus, let's say, 2x minus 1, something like that. That's an example. We call this a quartic. Okay? So if I have the highest degree of 4, that's called a quartic polynomial, and this would look something like, or this. Okay? So, do you notice any pattern at all with the graphs based on the degree? They do get more bumpy. More squiggly?
The odd numbers they always go diagonally, and the even numbers too.
Okay, that's a good point. Okay, so on odd numbers, they're kind of all going opposite directions, and even numbers are kind of going the same. Okay, it's like the evens are bumpier parabolas, and then the odds are bumpier lines. Okay, I take that. What else? Anything else you can see? You got it, Casey. What is it?
They all have like 4 separate parts to it. So like the quartic one goes up and then down, up and then down, and that's 4.
Right. So their degree tells you how many degrees of changes are going to be. So notice I have 1. I have 1 direction. If I have 2, I have 2 directions. If I have 3, I have 3 directions. And if I have 4, I have 4 directions. So what would 5 look like? If I did x to the 5th, that would be 1, 2, 3, 4, 5.
We don't talk about that.
No, we don't, but I'm just throwing that out there. Right? So there's as many changes of directions as there are degrees. So if I have 4, I'm going to have 4 change of directions. If I have 5, I'll 5, etc., etc. Okay? So the degree will affect the graph. Okay? Alright, so let's look at our examples on the bottom here. You basically want to state if it is a polynomial function. If I'm looking for a polynomial function, I need it to be a positive whole number, right? Okay, so I need to put it in standard form. I want to see if all my exponents are positive whole numbers. If they are, then it is a polynomial function. Okay, so let's put these in standard form. So I have the h of x. Alright, so what's the highest exponent that we see here? X cubed. Okay, and then I see it's a negative 1/4 x squared. And then it's plus 3. Okay, so that's in standard form, highest to lowest. Okay. Are all the exponents positive whole numbers? Well, I have x cubed, I have x to the second, and then I just have x to the 0, because that's what a constant is. So they're all positive whole, right? So it is, yes, it is a polynomial function. Okay, because they're all positive whole numbers. Okay? So number 2, we want to look at degree, and then we want to find out the name of it and what the leading coefficient is. Okay? So, number 2, what's the degree? The degree is 3, because that is the highest exponent. Okay? What is the name of that polynomial function? It is cubic. And then, what is the leading coefficient of that one? It is 1. Because the value in front of the highest is 1. Okay? Make sense? Alright, so letter B, let's put this in standard form. So standard form is going to be the highest coefficient, which is what? x5? What's my lamp on? Oh, negative 0.06. Yeah. So negative 0.0 or negative 0.6 x to the 5th. All right, then I have plus x, and then I have plus 2 over x. Okay. Well, if I have a variable in the denominator, how do I pull it to the numerator? Do you guys remember? I have to flip it and change the sign, right? Yeah, do the reciprocal and change the sign. So technically this would be written as negative 0.6 x to the 5th plus x plus 2 to the x minus 1. Okay, so to get that up, I got to flip it. So I flip it to the top, and then I have to change the sign. And there's a 1 right there, so it becomes negative 1. So are they all positive whole numbers now? No, they're not. That is a negative. So this is not a polynomial function. Okay, because x is a negative 1. Okay? Alright, so let's look at C. So I have g dx, so let's put this in standard form. Standard form is going to be the highest exponent, which is x squared, so it's going to be pi x squared. Then I have 7x, so it's going to be plus 7x. And then I have minus the square root of 3. Okay? So is this a polynomial function? Are all of my exponents positive whole numbers? They are, so it is. So it's a yes. Alright, number 2 is then, what's the degree? What's the degree of this polynomial function? 2. Alright, number 3, what is the name of it then? Quadratic, right? Because 2 is quadratic. So that's going to be the name is quadratic. And then 4, what is the leading coefficient? What is the value in front of it? Yep. Pi. It is pi. Okay, so that is the value in front of the x squared. So that's the leading coefficient. Okay? Alright, questions on that? Can you see that okay? Okay. So, figuring out the degree, knowing the name based on the degree is what you're going to need to know, that relationship, you need to know that. And then being able to pick out the degree and the leading coefficient once you put in standard form. So that's kind of the key points out of that. Good? Alright, flip. Alright, so we've done this part before, so we're just kind of reviewing it, where you're given a function, so this is our function right here. Okay? And then it's giving you the, like, it either says like f of x, p of x, g of x, whatever, and basically what it's stating is that when it says find p of 3, it wants you to put this value in for the x and solve. Okay, so we've done this in the past, where it says if x is this, what is the actual answer, right? So you have the equation that says, or the function that says p of x, and now it says find p of 3. So what that's saying is find this value when x is 3. Okay, so I take this value and I plug it into this equation. Okay, So I'm going to do P of 3. And then I'm just going to take 3 and plug it in here. So I have minus 3 cubed plus 3 squared minus 3. So wherever I see x, I take that value and I plug it in. Okay? And then I just solve. So 3 cubed is 27. 27 times a negative is going to be negative 27. I have 3 squared, which is plus 9. And then I have minus 3. So I have 27 minus 3, which is a negative 30, plus 9. That should be a negative 21. Okay? So when it says evaluate the polynomial, it gives it to you and it asks you to find it. You take that value and plug it in. Okay? So try to do B on your own. Okay, we have p to the negative 1. So try and do what we just did with 3, but now for negative 1. And I'm going to give you a warning. Make sure you use your parentheses because it's going to make a difference if you don't. Okay? So go ahead and see if you can't do that on your own. Okay? Because when you rewrite this out, it's going to be minus, and it's x cubed, so it's going to be negative 1 cubed plus negative 1 squared minus negative 1. And so you really want to make sure you have your parentheses around the negative because that makes a huge difference. So then this becomes minus, well, negative 1 cubed is negative 1. Okay, negative 1 squared is positive 1. And then negative 1 times the negative 1 is a positive 1. Well, this right here, the negative to the negative becomes a positive, so this just becomes 1 plus 1 plus 1, which is 3. Okay? Alright, so we're going to look at it in a little bit more advanced state. So now we have two functions. We have a p of x, and we have a q of x. Okay? And so we had the same concept, but now we have to look to the one that it's asking for. So when it says find p, I'm looking to this equation, or this function here. If it says find q, I'm looking to this one here. Okay? So you have to look to the exact one that's asking for. Okay, so when this says find p a cubed, you do the same thing, but you're using a variable instead of a number. Okay, so when you do that, you're not going to get an answer, like a number. You're going to get a new function. Okay? So I have p a cubed. So take the a cubed and you plug it in here. So let's look at this. We have p of a cubed is going to be 2. Where I have x, I'm going to put a cubed. So whenever I see x, I substitute this value for it. I don't change anything else around it. I just take what x is and now I change it to this. So I have a cubed instead of x, and that's being cubed, so I carry that as well. So you don't get rid of anything. You just take the x and substitute a cubed for it. And I get plus 6. There's an x, so I'm going to take it and multiply it by a cubed. And then I get minus 12. Okay, so I'm just taking this value and I'm plugging it in to those. Okay? And so now I multiply through. I'm going to do my exponents first. So I'm going to get 2 times a cubed to the cubed root is going to be a to the 9th. And then I have plus 6a cubed. And then I have minus 12. Okay? And so then that's the answer. Like you have a new function. Okay? Does that make sense what I just did? Okay. Alright, so now we have another example. This one says find 5, and then there's a bracket, Q, and then it's in parentheses 2A. So you always, just like you do with, oh yeah, question?
Sorry, is it a to the 9th or a to the 3rd?
A to,
on the left side.
A to the 3rd.
Okay.
It's just saying that that is what I plugged in to get that.
I would just do 9.
3 times 3 is 9.
Oh, you're just multiplying, not actually.
Yeah. Yeah. So that cubed is to that value right here. So I do this first. So that's a to the 9th, and then I multiply to the 2. Okay? Alright, did I answer that question? You guys good? Okay. So now I have this one. Now this one has a bunch of brackets and parentheses. So just like we do in normal, any equation, you work from the inside out. Okay, so we deal with the middle stuff, you know, anything that's like in parentheses, and then you work your way out. So we're going to work with the middle. So we have the Q2A comes first. So basically what that's saying is go to the Q function and replace it with 2A. Okay? And then once I get that value, I'm going to then take everything and multiply it by 5. Okay? So I'm going to do Q2A first. So I have Q2A is going to be, I take this function here, so I have 5. Where I have x, I'm going to replace it with 2a, and that's going to be squared, because it's 5x squared, so that 2a goes in there, and then plus 4. Okay? So when I simplify this right here, I have 2 squared and a squared, so it becomes 5, 4a squared, because I have to apply it to those two first, plus 4. Okay? And then I multiply the 5 through to this one, so I'm going to get 20a squared plus 4. And that equals my Q2A. 2 squared and a squared. So to apply this to both. Okay? And then I took the 5 and applied it to the 4. Does that make sense? Okay. So now, I still have this 5 on the outside. See how it says 5 bracket? So that means this whole thing needs to be multiplied by 5, because that's what that is. So I'm going to take my 20, okay, a squared plus 4, and I'm going to multiply it by 5. So that's that part right there. So once I do that, I'm going to get 100 a squared plus 20. So 5 goes to each term. Bless you. Okay? And we've done something very similar to this before. I feel like this is more a review of just basic math, how to work your way, multiply, etc. So, questions on that? So, again, it's 5 bracket Q 2A. I'm taking the value inside the bracket in the parentheses here and applying it to where it's x. And then once I get that, I'm going to multiply 5 to each of the terms, to whatever I have. Okay, so like you work from your inside out. Yeah?
What's the Q? Like, why is the Q in the equation then?
It's just saying that this function, they're giving it a value. They're saying Q of x. Like usually you see it as, you could see it as like f of x, Q of x, G of x.
No, I'm talking about, like, it says find 5 and then Q2 of A.
Basically what it's saying is it wants you to substitute 2 of a into this function, into the Q function, which is right here. See how it says Q of x right here?
Got it, okay.
Okay? And so it's just referring to that function. And where this is like, where you would, you know, probably like, whatever, why do I care to know this, or what does it matter? We're not going to get into the story problems of this, but how this works is as follows. Let me just kind of give you an example. Okay, have you guys ever gone into a store in which there is a percentage off and you have like a dollar amount off? Have you guys ever had that? Like, so, like you go to Kohl's, you have $10 Kohl's cash, or you have Kohl's cash, and then you also have like a 20% off Kohl's. Have you ever like experienced that, right? There's like, if you go in and you want to know, is it more, do I save more if I get the discount first and then give my cash, or do I save more if I give my cash and then get my discount? This is the type of situation. Because what you're doing is you're substituting in the answer of the ones, like you have your dollar amount, right? So let's say I have, let's say I'm going to buy $50, I'll say $60 of clothes, okay? I have a 20% off, and I have a $15 gift card, okay? So I want to know if I will save more money by getting the discount first and then using my dollars, or using my dollars and getting a discount, okay?
You'll save more money if you use your discount first.
Okay, well let's see. So this is a situation in what you are doing. You are taking a value and you're substituting in and getting an answer. So this is that type of situation, okay? So let's just see. Okay, what is 20% of 60? Anybody? Yes, it is $12. So if I take 60, I minus 12, so this is the 20% off first, okay, I'm going to get 48. okay, and then I subtract my $15, right? So I get 33. So I'm going to pay $33 if I take the 20% off and then my dollars, okay? So let's look at this. Let's take 60, let's subtract my dollars. I have 45. What is 20% of 45? And so that is going to be 34. So I save money if I take the discount first and then I subtract my dollars. Okay? So this is a situation in which you would then you apply the one situation, which is 20% off, and then you do the dollars, versus you look at the dollars and then you do the percentage. Okay? So this was the dollars and this was the percentage. You don't see it in this situation because there's obviously no word or verbiage to it, but that's the type of problem. You would create an equation that I just said, like those type of things, and then you would do the substituting. If I put this in for this versus this in for that. This is what we're trying to actually mimic, is substituting in something to seeing what the answer is and then doing comparison. Okay, so it seems like it's just a bunch of randomness, but this is actually a huge application that businesses and, you know, consumers, if you want to set up your equations, can do. Okay?
Typically when you go into a store, they'll have it where when you use like a gift card or like Kohl's Cash or whatever, they'll act as if it's a payment type.
Okay, here we go. So here we have where it says find 3p of a minus qa plus 1. So the letter signifies which equation you're looking at. So when I see find p of a, I'm focusing on the p function for this part, and when I say minus q this, I'm looking at the q for this part. Okay, so the letter indicates which function you're looking at to substitute into. Okay, so those letters mean something. Okay, so this really is like 3 times, and I have p of a, so I'm taking a, and I'm going to substitute it in for that x. So I'm going to do 3 times, okay, a, so I have 2a cubed plus 6a, okay, because I have 6x, take a and substitute for x, minus 12. Okay, so this a goes into where the x's are. Okay, so then the whole thing's being multiplied by 3 because the 3 is on the outside. Okay, then it says minus q of a plus 1. So what it's saying is take a plus 1 and substitute it to where you see x. So this is going to be minus, so I'm looking at the q one right here. This is my q equation. So I'm going to do 5. Where I see x, I'm going to do a plus 1 squared, because it's x squared. So I take that value and plug it in, and do plus 4. Okay? At this point, you guys, then you want to just solve it. Okay? So this whole thing is going to be subtracted. So we're just going to go through and kind of do the basic math. So we have 3 times 2a cubed, that becomes 6a cubed. You get 3 times 6a, that's plus 18a. You get 3 minus 12, that's minus 36. Okay? This one becomes minus 5, and this is going to be a plus 1 times a plus 1 plus 4. Because that's a plus 1 squared. A plus 1 squared is going to be a plus 1 times a plus 1. Okay? This is helping you guys study for your final, because this is all basic math that's going to be on it, right? Alright. So if I work this here, this becomes a squared plus 2a plus 1. I'm going to put my 1 there. Okay? That's all multiplied by a negative 5. Okay? And then this is subtracting the 4, so it's going to be a minus 4. Well, because this whole thing right here is being subtracted. See how this whole thing's being subtracted?
Oh.
Yeah. So I just added it on there. Okay, so at this point you would work through the whole entire math. Multiply the negative 5 to the a squared, the negative 5 to the 2a, the negative 5 to the 1, and then you combine all like terms. Okay? Does that make sense? You guys need me to walk through that, or can I just give you the example? Or the answer? Answer? Did it go through it, or answer? Alright, so the answer then should be, if I calculate this correctly, let's see, we're going to have 6a cubed, okay, we have a negative 5a squared. Okay, we're going to have an 18a, and we're going to have a negative 10a, so that's going to be a positive 8a. And then we have negative 36, a negative 5, and a negative 4, so it's a negative 39. So I have negative 36, I have a negative 5, I have a negative 4. I think I added that correctly. No, negative 45, negative 45, negative 45, sorry. Negative 45. I can't subtract correctly. Okay? Good? Questions on that? For our next area that we're going to be talking about, we're going to be focusing on two words. And those two words are what we call end behavior. Okay? And we've heard this a lot this last semester, and I said, you don't need to worry about it, right? Remember that? You don't need to worry about it when we're talking about graphs and behavior. I'm like, don't worry about it. Well, guess what? We're starting to talk about now. So, it is actually a very simple concept, but students tend to get confused. So I just want to focus on these two words. When I look, we're talking about graphs, and we're talking about what's happening with a graph. It's basically end behavior. So if I would just draw a line, okay, regardless of what it looks like, we have how many ends of the line?
2.
We have 2 ends, right? What signifies an end of a graph? It's where the arrows are, right? So our ends are where the arrows are, right? They're where the lines are going on both sides. Correct? Does that make sense? Okay. So when you see end, hopefully then you'll start thinking what's happening with the both sides ends of the line, right? Does that make sense what I'm talking about? All right. So then we have the word behavior. All right. When someone is saying your behavior, what are they usually meaning to? Like what you're doing, right? Right? What's your personality? What are you doing? So when we talk about behavior in a graph, we're talking about what is it doing. Okay? So when we talk about end behavior, what we're asking is, what are the ends doing? Pretty much. Right? What are the ends doing? And we can look at a polynomial function and not have to actually physically do a t-chart, and we can generally draw it out on a chart. Okay? It may not be perfect to where it is on the x and y axes, but you can just draw how many squiggles it might have, and then if it's going up or down or up or both down. Okay? So when we talk about end behavior, we're talking about what are the ends doing. Okay? Does that make sense? Okay. There is a pattern on what the ends are doing, and you guys kind of figured it out when I did this. You kind of were saying, and I think Kaven, you said this, or someone said this about how the direction they were going. You know, they're both going up, or they're both curved, or they have more squigglies, and they're going opposite directions, whatever. So there's a pattern to these, okay? And the pattern has to do with the degree of the exponent, okay? So when we talk about the degree of the polynomial function, we put it in standard form. Whatever the highest exponent is going to determine what's happening with the ends. Okay? We have two options. We have if it's odd or if it's even. Okay? So even, 2, 4, 6, 8, odd, 3, 5, 7, whatever. Okay? So that's it. Two options, odd or even. So when it comes to degree, it's going to tell us if they're going in opposite directions or if they're going in the same direction. Okay? So I'm going to focus on even first because we're used to seeing even. What is the most even common polynomial function we're used to seeing? The parabola, right? Well, okay, so parabola is x squared. We know a parabola is either a smiley face or a frowny face, right? So what are the end behaviors doing? Are they in the same direction or are they in the opposite direction? They're going in the same direction, right? They're both going up or they're both going down, okay? So when we look at the leading coefficient, or the degree of the polynomial, okay, so we talk about end behavior, okay, we want to look at the degree. Okay? And when we look at degree, we need to know, is it odd or is it even? So let's look at even. Even we have like x squared, x to the 4th, x to the 8th, whatever. Okay? We know that that's going to give us a parabola of some sort. Now the parabola may be curved, or it may be like this. It may be curved down, or it may be curved like this. But in the end, the ends, the behavior is they're going in the same direction. Does that make sense? Okay? So you have to ask yourself, well, how would I know what direction it's going into? Well, that's where you look to the leading coefficient. If the leading coefficient is positive, so like it's 2, if it's 4, 8, whatever, okay? It could be 7, it could be 5, it doesn't matter. They're all positive. Remember what I said, a parabola, when it's positive, what are we doing? We're smiling, right? So when we smile, we're positive. So if you can remember parabola, a quadratic equation is even, and when you're happy you smile and it's going up, then you have pretty much just narrowed in everything else, because everything just falls off of that. So if I have a positive and I have an even degree, I'm going to have a graph in which it curves up, where my end behaviors are both going up. Okay? If I have an even degree and it's negative, again, what happens when we're negative? We frown, right? So I have a negative, like -2, -4, -7. I'm frowning, so I'm pointing down, okay? So here I have a negative with an even, I'm pointing down, okay? And those are my ends. Okay, does that make sense? So just being able to indicate the degree and the leading coefficient shows us which way the graph is going to be going, right? So let's look at odd. If I have an odd degree, so this is going to be like x cubed, x to the 5th, x to the 11th, whatever. They're odds, okay? And when I'm odd, I have it where they're in the opposite directions, okay? So when I have the even, when I have odd, they're in opposite. Let's say you can't remember that. Well, remember how the degree tells you how many times there's a change, right? Okay, so if I have x cubed, I'm going to go 1, 2, 3. Well, notice how then they're opposite. Or I could go 1, I'm going to do it this way, 1, 2, 3. They're opposite. Okay, so if you can't remember, just sketch it out, and then you'll see which way the ends are going. So you notice how the ends are going opposite, right? So we talk about positive leading coefficient or negative coefficient. Well, this has to do with like the slope of a line. When you have a positive slope, which way is the line going? It's going up, right? When I have a negative slope, which way is it going? It's going down. Okay? So that holds true. Leading coefficient being positive, it's going to go up. The leading coefficient of being negative is going down. So by using the degree and the leading coefficient, you can have a general idea of what the graph can be sketched out as like. Does that make sense? Okay? So why does this matter? Because this tells us what the end behaviors are doing. So when we talk about the ends, these are the ends for each one of these graphs, right? They're the ends of the graph, and then we're asking, what is their behavior? What are they doing? Okay? So you have to look at the degree and the leading coefficient to kind of get an idea of what the curve looks like, and then you have to look at the ends and say, what are they doing? Okay? Well, how we do this is we kind of look, how do we read? Left to right, correct? Okay? And on a graph, left to right, okay? On a graph, left to right, is our x, right? Correct? And so this is negative infinity x over here, and this is positive infinity x over here, correct? So I'm going as negative to the x I possibly can to my left, and I'm going as positive infinity to my right. Does that make sense? Okay? So when we talk about end behavior, we're just saying when x is as negative as infinity, what is the y value doing? And then when I'm as x is going to infinity, what is my y value doing? So we're looking at when x is a negative infinity, what is y? And when x is a positive infinity, what is y? Okay, this is the end behavior. That's what we're looking at. We're saying what is happening to y when x is to the left and when x is to the right. Okay, so it's like the left and that's the right, because that's how we read. Okay? So, if I look at let's just do the even ones first. When I just look at this, and if I draw like a graph, like a chart like this, okay, here's my x. When x is negative infinity, which is this, my left side, what is y doing? Is y a positive? Is it y infinity, or y is negative infinity? It's infinity. You're going to have two answers for these, infinity or negative infinity. That's it. Your end behavior is either going to be a positive infinity, meaning it's going up, or it's a negative infinity and it's going down. Those are your two answers. Does that make sense? Okay? So then as x is going to infinity, as x is going this way to the right, what's y doing? It's going up. So what is that? Right? So as x is going to the right, what's y doing? It's going up. Correct? That's infinity. So if I'm going up this way, this is infinity. This is where y is infinity. If I'm going down, this is negative infinity. Okay? Does that make sense? So then let's look at, if I have a negative leading coefficient, it's facing down, right? So then as x is towards the negative infinity, what's happening to y? It's negative infinity, it's going down. If I go to positive infinity, what's happening with y? It's going down. So these are the same, okay? And these are the same because of the even. All right? If it's a positive, it's going to be positive infinity. If it's a negative, it's a negative infinity. Okay? Does that make sense when I'm talking about end behavior? What's the behavior of the line? All right, so let's look at then odd. So odd is going to be opposite. You're going to have opposite. So y is going to be a negative infinity, or it's going to be infinity, negative infinity. I feel like I can't say that word anymore. Infinity. All right, so as x is, if you draw a little line here, as x is over here to the left, what's happening with y? It's going down, so therefore it's negative infinity. As x is going positive, what's y doing? It's going up, right? So it's a positive infinity. Okay, so you're looking at what's the end behavior, what's happening with the ends. So as on this one here, okay, so as x is going towards the negative, so what's happening with the y? What's happening with y? It's going up, right? It's pointing up, so that's infinity. If it's going to the right, what's happening with y? Negative. So basically, as the arrow tells you if it's positive or negative. If the arrow's pointing up, it's positive. If the arrow's pointing down, it's negative. It's really, really simple. If you can just know that odd is opposite, and then negative or positive is up and negative is down, you can literally sketch it in 2 seconds. Okay? All right. So let's flip. So find the end behaviors. We have p of x. We have 2x cubed plus 6x minus 12. All right, so I need to look at the degree, and I need to look at the leading coefficient. That's all I need to look at. So what's the degree of this one? 3. Is the leading coefficient positive or negative? Okay, positive. So this is odd. So I have an odd positive. So I, right now, should be able to know that it's going to look something like this. Because I have 3 curves, right? It's 1, 2, 3. They're going to be opposite direction. It's positive, so it's going up. Right? Does that make sense how I did that? So I have end behavior here, and I have end behavior here. So what is my y behavior right here? So as x is going to negative infinity, what is y doing? Negative infinity. As x is going to positive infinity, what is y doing? Positive. Okay? Right? So as x is going positive, y is going up. So this is going down, so it's going to be negative. This is going up, that's positive. I mean, it's seriously, like that. So these are negatives, these are positives. Okay? Does that make sense? All right, so let's look at this one. What is my degree? 4. What is my leading coefficient? It's 5. So is 4 odd or even? Is 5 positive or negative? It's positive. So I have an even positive. So what do we know about even graphs? They go in the same direction, right? So what do we know about positive? It goes up. right? Because we're positive, we're smiling. So I know that it's 4, so it's going to go 1, 2, 3, 4. It's going to look something like that. Right? I didn't have to do any T-chart, nothing. I can pretty much be able to look at that and be able to kind of do a general sketch. So what is my end behavior? So what are my y's? As x is a negative infinity, what is y? It's going up, so it's what? Positive infinity. As x is going to infinity, what's y doing? It's going up, so therefore it's what? And since they're both going up, they should be the same. Okay? Alright, try C on your own. Try C on your own. See if you can't find the degree, the leading coefficient, do a general sketch, and then indicate your end behaviors. Okay? Give it a shot. Alright, let's see what you got. Alright, so the degree is what? It's 5. Is that odd or even? It's odd. Alright, my leading coefficient is what? Negative 2. Is that positive or negative?
Negative.
Alright, so I'm going to have where it goes 1, 2, 3, 4, 1, 2, 3, 4, 5. Something like that. Okay? Yes. Is that good? Alright, so I have it going in opposite directions because it's odd. It would be opposite direction. Because it is an odd, it starts from the top and goes down. So my end behaviors are here and here. So as x is negative infinity, y is going up, right? It's going up, so y is positive. As x is going to infinity, this way, y is down. Okay? And we always read left to right. So the negative infinity for x will be first, and then the infinity will be second. Question?
How do you know where to start it? Like, you started yours up here, you know, 1, 2, 3, 4, 5. I went this way. Does that matter? No, I know, but then for the other one,
So
it's odd also, but you started it down.
Because the leading coefficient. The leading coefficient tells you the direction of which way your graph is going to go. So if it is a positive, it's going to be like a positive slope, so it starts from the bottom and goes up. If it's negative, it's... Okay? Alright, so then just kind of to reiterate regards to graphs, you guys, I'm going to show you again how they work. So if I have a 0, so let's say it's x is 0, you're going to have just pretty much a straight line like that. Okay? If I have an x to the 1, okay, you're going to have a line. It's going to look something like this. Okay? If I have x squared, you're going to have a parabola. It's going to be something like this. Okay? If I have x cubed, it's going to be like this. So if I have x to the 4th, it's going to have 4. Like that. And then like x to the 5th, etc. Okay? And so the degree tells you the type of curve, and then what tells it if it's up or down is going to be the leading coefficient. The leading coefficient is positive, the leading coefficient is negative. Okay? So then it tells you which direction it's going. Okay? So this tells you what the graph looks like in regards to how many curves. This tells you the direction of which way it's going. Does that make sense? Does that help a little bit? Okay? So when it asks for what is the end behavior, you are looking to see what is happening with the ends. Okay? What are the ends doing? Does that make sense? Alright, so you have about, not quite 15 minutes, about 12 minutes to actually, 14 minutes to work on the rest. You have, and then we'll take 2 seconds. If you flip to the back, you're doing the same thing for all three. Basically, this one is already graphed for you, but basically you want to state what the end behaviors are on this one. Okay, this is just stating the end behavior. You would indicate if it's an odd or an even, and then it says the real zero, so just basically where does it cross how many times it cross the x-axis. On 13 and 21, you guys are just drawing the general sketch that we, don't do it. You don't need to do a table. Cross out with the table. You just want to do a general sketch, okay? Just kind of like what I did. and then indicate the leading coefficient, the degree, and then what the end behavior is. Okay? Does that make sense? So that should be really, really quick. You should, if you got through this, you should be done with this in literally 5 minutes, not even. Okay?